Hi everyone, my name is Joshua and I'm a research associate at the Institute of Medical Informatics and the IT Center of Clinical Research at the University of Lübeck in northern Germany. I'd like to talk to you about Termikron, a system we've developed to bridge the gap between terminology servers and metadata repositories today. So first I would like to start with talking about why metadata is needed in this modern world of big healthcare data. So obviously the amount of data is increasing every year and we want to make use of that data for secondary use in research studies and so forth. However, because the field of healthcare is very broad and comprehensive with multiple different areas of study, each with their own naming systems and requirements, and always a dependency on context. There are innumerable data models which capture essentially the same information. So what is metadata from a theoretical point of view? Generally, it's referred to as data about data, but a more formal definition would be structured atomic units of information that describe data in some way or another. So besides the data type shown here or the date representation, we can also define semantic association and relationships between the entities. For example, if one data element like status of smoker is used throughout the data model, we can use that over and over again, or we can define mappings between similar data models as shown earlier. And we can also define annotations between those data elements using SNOMED CT or other standard terminology. To store that metadata, the provision of metadata repositories is a powerful approach. So those metadata repositories obviously provide metadata at the schema level. The attributes, data types, relations, annotation, and so forth, as shown on the right. And there are a number of relevant standards, for example, ISO IEC 21526 and 11179, which define requirements for medical data metadata repositories. At the end of the day, metadata is generally used to aid in data processing. So metadata repositories can facilitate something like this, where we can have an incoming schema, an export schema, and then we can have relations between those elements that map between those attributes or call some kind of function to transform those attributes to another. However, going there actually requires a lot of domain expertise, and this is often a very significant investment of money and of time, because you will need to involve healthcare domain specialists for your mappings and descriptions. So if we want to define this kind of mapping, we first have to define both our schemas in terms of data elements, catalogs. Then we have to bind those data elements to the same catalogs. We have to group the elements in profiles and data element groups, and we have to annotate them with SNOMED CT and other standard terminology. And once we have that, we can define relations between those two schemas, which then allow us to take back the information we get from the MDR. However, because those processes are actually quite involved, there is often a lot of duplicate work within the same organization, but also on a national or larger scale, where data elements that have been defined previously cannot be reused throughout the MDR. So one way to reduce the amount of duplicate work is the definition of standard terminology and value sets, which are subsets of those terminologies that are used in a specific use case. So that would mean that concepts are identified consistently with codes and represented with adequate and expressive terminologies throughout the entire data model. So that means, for example, the use of something like SNOMED CT, which is a very powerful terminology that has a lot of facilities for reasoning with machines, which can infer relationships between the data based on the concepts given in the data model. So we have to define those use case specific code lists somehow, and those code lists, for example, could be a list of all neoplastic diseases versus a list of all fractures from SNOMED-CT for this specific use case of capturing information regarding those diagnoses. However, we have to distribute those artifacts somehow, otherwise we haven't gotten anywhere. So that's where terminology servers come in, which provide the common code systems, those value sets, and also mappings between code systems and value sets. And these systems have to support the processes of creation, maintenance, and query of those resources. One standard that has been increasingly relevant for the definition of terminology servers is HR7 FHIR, which provides not just the core FHIR specification, but also a subset which is aimed at the creation of terminology servers. So there are 3 different resources defined within HR7 FHIR, namely code system, value set, and concept map. We only consider the first 2 for the purposes of this talk, which define a very mature data model for those terminological artifacts. And there are also operations defined which allow users to interact with the server using REST APIs. So FHIR has been extremely relevant for the provision of national terminology servers in the last few years. For example, there is a drive to institute such a server in Germany, and there are also already infrastructures running in Australia, the Netherlands, and the United Kingdom that we are aware of. However, there is quite a bit of overlap between MDRs and terminology servers, because obviously we want to bind our artifacts or definitions to standard terminology, and that has to be a fundamental feature of those MDR implementations that currently exist. So what the creators of MDRs do is allow users to create those value sets, I would call them, within the MDR directly, and redefine whatever has been encountered in the instance data. However, this really falls down once you start to consider complex terminologies like SNOMED-CT, which not only has about 360,000 pre-coordinated concepts with a lot of relationships between those concepts, but also a grammar for post-coordinating those expressions and concepts, which basically defines new concepts. And the same goes for larger value sets which reference multiple terminologies. So we would argue that terminology does ultimately not belong in MDRs, and we would rather advocate for a responsibility split between MDRs and terminology servers. So this is what this responsibility split might look like, where we have an MDR and a terminology server which are separated by a boundary, but they are able to communicate over REST APIs or some other mechanism. And the MDR is able to reference the terminology defined in this terminology server for binding and also for annotation, and it is able to query those resources at runtime to support users and domain experts when they define those data elements in the first place. And obviously that would require the coordination of the maintenance processes between those systems, so that terminology remains consistent with what is referenced in the MDR. So the two systems would ultimately be kind of loosely coupled and have high cohesion, so they only deal with whatever they are required to deal with. But sadly, this responsibility split is not currently supported by any MDR implementation that we are aware of. So unfortunately, there is always a constant redefinition of value lists of the same atom of information. So to address this problem until this responsibility split is supported by the MDR implementations on the market, we propose a stopgap solution that bridges between the two systems until we can go where we want to be. So we propose that terminology server resources, namely value sets, but also to some extent code systems, drive definitions in the MDR and drive the creation of catalogs or concept systems in MDRs. So that would mean that we have to take in FHIR resources from somewhere, and we have to convert them somehow to suitable representation for the MDR that we want the resources to be provisioned in. And in the process, we have to handle the requirements of the MDR systems transparently, so that authentication, for example, is handled by our system. So we have developed a system that we've called Thermikron to bridge this gap, and this is a very adaptable pipeline to provision those resources in a number of MDR implementations. So regarding the input part, we currently support 4 different routes, namely FHIR terminology service, obviously, but also the input from the FHIR system, from node package management registries like Simplifier as the most important representative of those systems, and also using the SNOMED-CT ECL expression constraint language, which is a query language for basically querying SNOMED-CT for a subset of concepts that conform to the specified definition, for example, all fracture codes again. And on the output side, we support currently 3 different systems. The first is QL for MDR, query language for MDRs, which is a GraphQL-based language for federated MDR implementations. And that's also very interesting because QL for MDR could be implemented by MDR maintainers as basically a facade to the internal data model, so that it can be interacted with using other MDR implementations using the standard GraphQL-based query language. And we also support currently 2 different concrete MDR implementations, namely Centrax MDR, which is a proprietary solution, and Samply MDR, which is an open source project. We have developed a very powerful command line interface to interact with all of those routes and to provide the parameters for that. So it is a very scriptable solution, and it can be used for the automatic provisioning of those resources in terminology, from terminology service in MDRs. And we have released this system as free and libre open source software at the GitHub link shown under the image. So to show you some results, this is the GUI we've implemented, which is used to create suitable bundles for the distribution of terminological artifacts via file service, because generally you would not want to upload everything that is provided on a FHIR terminology server. So once our system runs, it creates the resources provided by the input method into the MDR configured in the output route. And this is what one code system converted to FHIR looks like, left in the Centrax MDR and right as the QL for MDR representation. To sum things up, we've developed a free and open source software to create those FHIR resources in MDRs, even though they don't directly support a responsibility split. And because we have released the system as free and open source software, we would be very happy for the community to add support for other MDR implementations, which we haven't considered so far. Because we support QL for MDR, we are also able to support MDR implementations which provide this facade, even if they might not internally comply to the relevant concept model and standards. But at the end of the day, we really want the MDR community to move towards this responsibility split, where terminology does not belong in MDRs and the MDR queries terminology service at runtime. I would also like to add that this responsibility split has been anticipated by the newly 2019 ISO standard 21526, because that standard actually makes provisions for the external reference of terminology. So our solution is very much a stopgap solution, but it has been working quite well for us to upload those resources in MDRs. And drive reuse of code systems and value sets. So with that, I would like to very much thank you for your attention, and if you have any questions, I would be happy to answer them. Thank you.